Hello everyone, welcome to my channel EC Point. Today I am going to discuss about OR gate and NOR gate circuit representation using NPN transistor. So let's start. So this is the OR gate circuit representation using NPN transistor. So from the truth table of OR gate, we can say that when the two inputs of OR gate is in lower state, the output will be lower. Otherwise, the output will be higher. So now in first case, where A and B, both the inputs of OR gate remain in lower state, 0, 0. In this case, A is 0, B is 0. Then what will happen? Both T1 and T2 transistor will remain in off state. So no current can pass through T1 and T2. So in this case, what will happen? We can see that this is the ground point, right? This is the ground point. The potential of ground point is 0 volt. In this case, both transistors are in off state. These two transistors remain in off state. In this case, the 0 voltage here, the 0 voltage will reflect in this here output, because we know that when IB, that means passing current through the transistor is 0. So I equals to 0. That means from the Ohm's law we know that V equals to IR. So I equals to 0. That means V equals to 0. So in this case, voltage difference between ground point and this point will be 0. Will be same. So the voltage of this point will reflect here in output. So in this case, output will be 0. Now in second case, where 0 and 1, where B is 0, A is 1, B is 0. That means T2 is in off state, A 1, that means IB is passing through. So T1 will remain in activated state. So in this case, what will happen? Current can pass through only T1 terminal, not T2. So in this case, what will happen? You can see that VCC, some amount of voltage are there in VCC. Then what will happen? This potential difference between this point and the potential difference between this point remains same, as we know that the resistance, the equivalent resistance of transistor is very much lower, is very much negligible. So in this case, there will no current drop, there is no voltage drop. So what will happen? The amount of voltage here will reflect here. So the output will be 1 higher. In third case, where B equals to 1, A equals to 0, B equals to 1, A equals to 0. So in this case, T1 will in deactive state, T2 active state. So that means current can pass through T2, not T1. Okay, so the potential difference between this point and the potential difference between this point remains same, as we know that the equivalent resistance of transistor remain is very much lower state, negligible state. So VCC, the amount of voltage VCC will reflect here. 1, output will be 1 high state. In case of 1, 1, where both inputs of OR gate is in high state, then what will happen? Both T1 and T2 will active state. That means both are in on state. Current can pass through both T1 and T2. So in this case, what will happen? The same case will happen. VCC, the voltage difference between this point VCC and this point will remain same, as you know that the equivalent resistance of T1 and T2 remain in very lower state, very much negligible state. So what will happen? The voltage if in VCC will reflect in output. That means output will be higher in that case. So this is the logic functioning of OR gate. Now come to the NOR gate. We know that the circuit representation, the working principle of NOR gate is just opposite to the OR gate. So this is the circuit representation of OR gate. Okay, so and this is the circuit representation of NOR gate. What's the difference? Difference is there. In OR gate, resistance is connected to the ground point, and in NOR gate, resistance is connected to the VCC point, right? So now, in case of NOR gate, from the truth table of NOR gate, we can say that when the two inputs of NOR gate is in lower state, the output will be higher, but otherwise the output will be lower. This is the opposite case of OR gate. So now in first case 0 0, when A and B both are in 0, both are in 0 lower state, then what will happen? T1 T2 will remain in off state. That means current can't pass through T1 T2. So what will happen? The voltage difference of this point and this point will remain very much negligible, as I equals to 0 according to Ohm's law. V equals to IR, so V equals to 0 obviously. So what will happen? The voltage difference between this point and this point will remain same. So what will happen? VCC will reflect here. So one higher output, we can get higher output due to the lower, both the lower input are here. So now in case of 0 1, B equals to 0, A equals to 1. B equals to 0 means IB is not there. So this transistor is in off state. A equals to 0. So this is on state. This remaining on state. Then what will happen? The potential difference between this point and this point remains same. As we know that the equivalent resistance of transistor is very much negligible. So the potential difference between this ground point and this point will remain same. So voltage at ground point will reflect here. So 0 will get 0 from here output. So now in case of 1 0, that means here this is 1, this is 0. That means in this case T2 will be activated, T1 deactive. So in this case current can pass through T2 only, not T1. So current can pass through like this, you know, this point, this, like this. So what will happen? The potential difference between this point and the potential difference between this point remains same, as the equivalent resistance of the transistor is very much lower, very much negligible. So the potential difference between the ground point and this point remains same. So 0, the output, we get the output 0 due to B equals to 1, A equals to 0. So now when 1 1, that means the both inputs of NOR gate remain in high state, then what will happen? Then both transistor will in on state. That means current can pass through T1 T2 both. Then what will happen? As we know that the the equivalent resistance of transistor is very much negligible. So what will happen? The 0 volt, the ground point, the 0 volt will reflect here. The potential difference between this point and this point remains same, as the resistance of this transistors is very much negligible state. So 0 volt will reflect here, so we can get 0 output. So this is the opposite case of OR gate. So that's all for today. In my next video I'll discuss about XOR gate. Thank you so much for watching my video.